Hey everyone, continuing with our sigma notation, we'll be talking about manipulation. Alright, basically, how do we manipulate a sigma notation when given the sum? And also, how do we actually manipulate a sigma notation when where the formula is actually very similar to the formula that is given? Alright, what do I mean? Now, let's just look at the first example. So we have the summation of r log r plus 1 over r from 1 to n, r equals 1 to n, equals to log whole thing n plus 1 whole thing power n over n factorial. Now the question wants to find the summation of the same formula, but now from r equals 1 to a plus 2. So essentially, right, it's actually very simple. You notice that the lower limit is the same. It's the same function. The difference is in the upper limit is now a plus 2 instead of n. But because n is basically any integer, right? Any positive integer bigger than or equals to 1, a plus 2 can also be an integer that's also equals to or bigger than 1. So essentially, you just need to sub n equals to a plus 2 into the formula. Alright, sorry, it's capital letter A plus 2. So essentially, this equals to log, substitute every n with a plus 2. So a plus 2 plus 1 will give you a plus 3 in the bracket, power a plus 2, right? Because it's not power n, so n equals to a plus 2. A plus 2 factorial as the denominator. Alright, so it's very simple. Alright, so therefore we have this general formula. Alright, if they give you the summation as of a function, and this equals to for some function g, right? Basically, same limit, but now any thing, right? So let's say k, f, r, sorry, this should be r, would give you gk. Alright, so it doesn't matter. Alright. Now, let's take a look at the second example. We notice that now, same summation, just that now, if you look at the question, it seems to be a different function, right? It's now r plus 1 times log r plus 2 over r plus 1. But what do you notice? It's actually a similar formula, right? It's just that now your variable is now not just r, it's now r plus 1, right? You notice r plus 1 versus r plus 2 versus r plus 1, r plus 1 versus r. Basically, if you notice over here, it's basically r plus 1 now. The variable now increases by 1. So what happens when a variable increases by 1? Let's take a look at the first summation, right? You're given n of from r equals to 1 to n. Let's say we give this function as fr, right? Now, basically, this means you get the summation of the first term all the way to the nth term, right? So r equals to 1 to n. But now you're tasked to find the term from 1, r equals to 1 to a plus 2. And now, because you notice that every r is now r plus 1, now your function is now f r plus 1. And this gives us f2 now, right? You substitute the first r equals to 1, you get f2 plus all the way to f a plus 2 plus 1 a plus 3, which is the same thing as summation of r equals to 2 to a plus 3 of fr. Alright, so what do you end up seeing here is that there's kind of a pattern, right? You notice. So let me just condense it over here. So let's say fa plus 2, r equals to 1, fr plus 1. Alright, if you want to convert it to fr, a summation of fr, you notice that r plus 1 to r is a decrease by 1, right? Because you decrease the inside by 1, the variable by 1, your limits will increase by 1, right? Now, similarly, or more like conversely, if you want to convert the function to fr plus 2, you notice you will get a reduction of 1 in your limits. Okay, how do I prove it? Very simple. You notice this basically f2. So if you have fr plus 2, it will be from 0 to a plus 1. Alright, so from here it's very simple. Now you know that this is basically a plus 3 over, sorry, a plus 3 as the upper limit, bottom limit r equals to 1, fr minus away r equals to 1, 1 fr, right? Don't forget, you're given the lower limit of r equals 1 in the question, right? R equals 1 over here. Therefore, your lower limit must also have r equals 1 to apply this formula that they gave you, right? Log n plus 1 holding power n over n factorial. Then from here, it's very simple. Now you just sub in a plus 3 as in the formula, like what we did just now. So we have a plus 4 holding power a plus 3 over a plus 3 factorial, minus away when r equals to 1. So minus away r equals to 1. So following the formula, we have log 2 power 1 over 1 factorial. So basically just log 2. So minus log 2, which is simply just divide by 2. I can just simplify it like this. All right. So to conclude, all right, we have these following formulas. All right. So if you have a summation of r equals 1 to n of, let's say, function fr, and we get gn as a sum, right? Because ultimately the terms will put r equals to n, so that's why the summation will end up with a variable n. This will simply mean that if we have a summation from r equals to 1, don't forget the lower limit must be the same. So let's say k plus h, where k and h are integers, then we have g k plus h. All right. Now, if we have a summation from r equals to 1 to n, fr is simply equals to, now, if you want to convert to a formula with r plus 1, we will then basically do the opposite, right? So if this increases, right, if the variable increases, let me draw the arrow properly, if the variable increases by 1, the limits would decrease by 1. So you get r equals to 0, and then n equals to, then top limit is n minus 1. Now, if you want to reduce the variable by 1, so from here, you go from minus 1, your limit would increase by 1, right? So it's basically opposite, all right? The idea is that now you need a higher r to get the same term. Therefore, you get r equals to 2 and upper limit n equals to 1, n plus 1, all right? So there we have it, sigma notation manipulation. Don't worry, I'll show you one more example in the next video.